information if you want to on those ones. So once we have that, we're going to talk about what we see when we get the scatter plot, what type of relationship we see. What we want to have in this class is a linear relationship. There are other types of relationships, but we're just not going to get into those. So we want linear relationship. We want the dots to be pretty close to being in a line. So you can see here, it's never going to be a perfect line, but it should be pretty close to being a line. So these look like they're pretty close to a line. So both of these are going to be good linear relationships. It's not going to be perfectly linear, it just has to be pretty close. We do have other relationships down here. You can see this one is a parabola. That is a relationship, but we don't want this one in our class. We will only want the line. Same thing here, this is cubic. It comes up and then down and then back up again. So this one's not linear, we don't want to use this one. This one, everything's just kind of scattered. There doesn't really seem to be a pattern at all. In that case, there's no relationship at all. So we want the two on the top, the two linear ones. And it can point up and to the right, it can point down and to the right. Either one's fine as long as it's linear. That's what we want. All right, so here's the definition. The two variables have a linear relationship if the data tend to cluster around a straight line when plotted on a scatter plot. So if we look at the graph we just did, these aren't perfectly in a straight line, so you wouldn't necessarily say that these dots are all on a line. But if you drew a line through them, so you put a line like maybe right there, you can see most of the dots are pretty close to where that line would be if you drew one in. This one's maybe a little bit off, this one's off by a little bit, but most of them are right there next to that line. So this example that we just graphed on our TI-84, we would say that that one's linear. It's not perfect, but it's pretty close to being linear. And so when it comes to a gray area of how close does it need to be to linear, we're going to get to that later. There's a measure for that, and that's going to be R, which we'll get to later today. Okay, and then they have, I think they have some definition problems on your homework, and so I kept all of this big block in here for you if you're looking back at your homework trying to figure out which one it's supposed to be. But they say two variables are linear, we'll say it's positively, that's what I'm trying to put in here, positively associated, and it says when above average values are associated with above average values of another, if you have below average values are associated with below average values of another. I think that's the wording that they use for the homework. You don't have to memorize that. You just have to know if you're looking at a scatter plot, when is it positively associated and when it's negatively associated. So two variables are positively associated if the value of one variable increases, the value of the other variable is going to increase as well. So if one variable increases, the value of the other one is also going to increase. They kind of tend to increase at the same time. And it's not that this one increases necessarily causes this one to increase. It's just the trend that we see is that if one increases, we tend to see the other one increase as well. Okay, so if you're looking on the graph, this one, if it's positively associated, this one is going to be going up and to the right. So if we look back here, at these two that are positively associated, this one, as your x gets bigger, if you go along this x-axis, your dots tend to go up as well, so they're going up and to the right. This one's going to be a positive linear association. The other one is just going to be negative, and that's fine. If you have a negative linear association, that's not a bad thing. It just means that if one increases, the other one decreases. So say that they are negatively associated if you have above average values of one is associated with below average values of the other one. So if the value of one variable increases, the value of the other one decreases. Again, with this one, we're just looking at the trend. We're not saying if you increase x, that y is necessarily going to decrease. It just means that if you look at your data values, as x gets bigger, your y tends to be bigger values, or sorry, smaller values for this one. And so this one, if you look at the scatter plot, this one is going to go down and to the right. So based on your scatter plot, if it's going up and to the right, we say it's positively associated. If it goes down and to the right, we say it's negatively associated. We're going to see those positive and negatives come up again in 4.2. Okay, so when is close enough to being linear? It's going to be when we, let's see, call it linear, and when is it too far away from being linear? That's what we're going to look at next, kind of where the cutoff is. So if we measure how strong the linear relationship is, that's going to be the correlation coefficient. So our correlation coefficient measures the strength and the direction of the linear relationship. And so that's just going to be a value that we find. We're going to use our calculator and not this thing. I'll tell you why when we get to that example. And so the linear correlation coefficient for us is going to be R. That's for the sample. We only use samples. We're never going to do correlation coefficient for the population. If we did, it would be called rho, but yeah, we don't need to worry about that. And if it was rho, we would just have an n down here instead of n minus 1. But our calculator doesn't even give us rho. They only ever give us R, so that's what we're going to do in this section. It's always R. All right, then they've got this big complicated formula here that sometimes they have. I think there's one question on the homework where you can put these numbers in and calculate what it is. Maybe that's for 4.2. I don't remember, but it's easiest just to use your calculator. We'll go through and but I'll show you one example of this one, how they use the formula, just so you can see it, but don't use it because really it takes about 10 minutes to do one problem using this thing. And if you put it in your calculator, it takes like 1 minute, so it's going to save us a lot of time. But that's R, the correlation coefficient. That's what we're going to be finding here. And so we've got our different properties for what R is going to look like. R is always going to be in between -1 and +1. So you're never going to have something like a 12 or a -2 or anything like that. It's always going to be like a decimal, either positive or negative. So you can get negative R's and that's okay. So here it says if R is +1, then a perfect positive linear relation exists between the two variables. And it says the points on the scatter plot are perfectly linear. I don't know if I can fit all of that in here. Perfectly linear. So they're all exactly on a line. That's not ever going to happen in like the real world. So it is, I mean, you can come up with an example, but having an example that you get from real life, it never comes up to be perfectly positive one. If you have -1, it's on the other side. So if everything is exactly in a line, but that line points down and to the right, then it's just going to be a -1 instead. So this one's going to be perfectly linear. They can come up with examples where that happens, but like I said, if you draw from the real world, it's not going to happen that way. It's never going to be exactly 1 or exactly -1. Okay, but those are perfect relationships. Like I said, it's not going to be perfect, but we want it to be pretty close. We want it to be pretty close to being linear. So we want our R values to be close to either +1 or -1, because then they're going to be close to being linear. So the closer R is to a +1, the stronger the evidence of a positive association between the two variables. So if you want to have a positive association, you want your R to be really close to +1. If there's a negative association, that's okay. It doesn't mean it's a bad thing. It just means that they're negatively associated. And if that's the case, your R is going to be negative, and it's going to be really close to -1. So when you're finding these R values, you want your R to be either close to +1 or close to -1, because that means you're going to have a really strong relationship. What you don't want to have is in between the two. So here you don't want R to be close to 0, because if R is close to 0, then you really don't have much of a linear relationship.